Hello everyone, welcome to the second video in the playlist about plotting data with Python. So already if you have not watched the first video, please go to the same playlist and then first finish the first video of this, and then this is the second video in the playlist. Now, we just did only 4 lines of code in the last part. We just imported pandas and we imported the matplotlib pyplot library. And since we are not plotted anything, since we have imported pandas, so from that pandas I'm using read CSV, and then we are reading some CSV text file and then printing the data frame. So let me just execute once again the same program, and then we'll see how the output will come. So basically, the program is reading, and then just a minute. I think I will slightly reduce the font size so that it looks better. So instead of 24, I go with font size of 20. So let me run the program again. Okay, so now we are having this data where this is the time and then this is the meter id which I mentioned, and then there is different parameters. So now let me explain what are these parameters that we are having. So again, this is how the data looks like. This is the sample data, and it starts from 0 minutes of a day to 20, 23 hours 59 minutes of a day. So the entire one day data will be there in one file. Now, what is the source of this data? The source of this data is an electrical energy meter. So it looks something like this. So here you can see the energy meter is there. So it's a sample this thing, and this is the data sheet of that particular energy meter. So let me just quickly show you what it is. So this is a digital panel meter, and it's called single function meter, or sometimes if it has more functions, it's called multifunction meter. And it is an electrical thing. Those who are familiar with electrical engineering, you know that there is a three-phase power, so it measures that, and different R phase, Y phase, and P phase things are there, and then there is a indication of which unit it is and all that. So this is that. So different rows have different displays. So for example, voltages are displayed in the first row, currents are displayed in the second, and then frequency and power factor, etc., are displayed in the third. I further go here. So different. This is just a three-phase four-wire, three-phase three-wire, one phase like this. So again, this is, you don't need to know all these things if you are interested in data manipulation. But then just for the domain understanding of it, this thing. So this is the memory map of the digital meter. So you can see what parameters are measured by this particular sensor or the meter. So this becomes the columns in our database. So for example, power factor average instantaneous, power factor of R phase, power factor of Y phase, B phase, then line to line average voltage, then RY, YB, BR, the combination, the line voltages of three phases, then line to neutral average voltage, and then R phase voltage, Y phase voltage, B phase voltage, total current, and then currents in RYB, and then frequency, and then whatever is a high current RPM, some more this thing. So the wiring connections are like this. So there's a load, and again, I'm going too much into electrical domain, but just understand that these are the columns. I will once again show you those columns. So here, how to mount it's all is there, and how to configure, how to troubleshoot, everything is mentioned in this. So just I wanted to give you this general overview of what kind of. So this is a data sheet of that particular source, that is the sensor that we are having. Now, if you want full understanding of this, so there is a YouTube video called Campus Energy Monitoring System, 1 hour 12 minutes. You search by this title, Campus Energy Monitoring System, and my own lecture, more than 1 hour lecture, you can find in this, in which I am explaining how the
Plug
campus
into a
energy
Raspberry
monitoring
Pi
is there.
module. And the Raspberry Pi module
So you can
gets
see this lot of
we have
how
said
the
is
data is
that close
visualized,
it's
everything
close
you
to
can see in this video.
we're
So
able to
I request you to please
configure
go
these
through
features.
this particular
But again, that
YouTube
is
video
optional.
to
You
understand
can meter if
the implementation aspect. However, for your further understanding, I'll just show you few pictures. So, for example, this is how the So this is the Google Map location. There is a college called VVIT where we had first installed one of the devices, this campus energy monitoring system. So here you can see there are few buildings and then there is electrical panel. So I will not go into details. So this is how a simple layout diagram looks like. So there is a main supply coming from the top and there is a generator on the right and then there is a solar power on the left. So the above part is the supply side and the below part is the demand side. So academic block, admin block, girls hostel, like this. So because it's an educational institute, so this is how. And then the panel looks like this. So on the right you can see the old panel is there, and we retrofitted the old panel with the metering panel on the left. So this was not here present before, but after we executed this project there, we have installed the 6 digital meters, and the seventh meter is already installed here in the plan in this, and we are getting this data. So as an example, so these are the wiring connections, and this is how the email can be generated. So anyway, so this I hope this gives you some kind of idea. So this is how the electrical energy data is coming. So now again, what are the parameters? Okay, so the parameters, let me now show that. So I already just labeled the parameters. So I'm just this is some other old code. From there I will copy. So now I'm coming back to my code, and instead of printing the plain data frame, what I can do is introduce the columns in between. Okay, so how do we introduce the columns? First, I create a variable called columns. So first column is timestamp, second column is meter ID, third column is total power of all three phases. That's the entire power consumed by this particular meter. I mean the load connected later to that meter. Then PR, PY, PB. These three are the R phase, Y phase, and B phase powers. So the total power is addition of all these three. Then power factor average, then power factor of R phase, Y phase, and B phase. Then we have ST. So ST is apparent power. So there is a actual power or active power and apparent power, two types of powers. And SR, SY, SB are three phases. Then voltages, average line voltage, RY, YVBR. Then phase voltages. Then we have currents, phase currents, and total current. And then the frequency of the system, energy running of the system, the energy units of the system, and then VAH, that is volt ampere hour, that is again a form of energy. So okay, so these are the parameters. Of course, today for plotting, I want to plot only PT. That means the total power consumed by a particular meter. So these are the columns. So first I will assign these columns to the data frame. So now you look at line number 3, a data frame is already created. So the data frame is created, but it did not have any what you call the titles for the columns or header for the column. Okay. So how to assign header for the column? So simply we write df dot columns equal to calls. Okay, so I could have directly given this here, but just for explanation, I thought this will be easy. Now I am printing the data frame. Now we'll see what will be the difference. Now if I go back to the terminal, so here you can see once the command is executed, there is no header here. So let me now print with the headers. I'm running a program now, and it will read the data and then also assign the headers to this. Okay, so now you can see here timestamp is there, then meter ID, then PT power in T phase power, that is total power, R phase power, Y phase power, B phase power, IR, IY, IB. These are currents, and finally last is the energy reading we are getting, and then one more column VAH is coming due to some reason here, but anyway that is fine. We have 29 columns of data and we are having 1023, that is 10,023 rows of data. Now we are interested only in PT, plotting the total power, so we'll do that later. So now coming to the meter ID, there are different IDs 12, 4, 6, 7. So in order to understand the meter ID, you should know how to by knowing what these IDs represent. So to explain that further, I have just created one small diagram. So please pay attention to this diagram. So we are doing this data analysis for a particular actual campus. Okay, so we have this is a practical real world example. So we have supply side above and the demand side below, and the power is flowing from top to bottom in the downward direction. Now, for this particular campus, there are several sources of supply. So, one is that they have grid supply. That means whatever power you are consuming, the entire you are getting supply from the electricity distribution utility or the grid. Now, DG1 and DG2 are diesel generators. They have two diesel generators. When these diesel generators will be used, whenever the grid is off, that means when there is a problem on the supply side and when the grid power is not coming. So, at that time, your DG1 and DG2 will be switched on so that you have an uninterrupted power supply to the demand. If these DGs are not available, the diesel generators, then there is no backup. Your grid is gone, means you don't get any power. You are completely in the dark. Next, we have solar PV also attached here. So, in fact, solar and grid together work with each other. So, as the sun shines in the morning, whenever the sun rises and the sun shines on this PV panel, it starts generating power, and the generated power will enter, and then it will go to the main block or cyber block or the high tech block. In between, we have the bus bars, which are all these things are all connected in parallel to this particular bus bar. Remaining power, so whatever is the demand, let's say the demand is 100, 100, 100, so we have total 300 as the 300 kilowatts of demand is available at a particular time. During that time, the power coming from solar system is only 170. So the demand is 300, power coming from the solar is only 170. Then the remaining 130 will be coming from the grid, assuming that DGs are switched off. See, usually nobody operates DG when grid is available because the grid power is cheaper and DGs are costlier. So normally these two DGs will be disconnected. They will be their output will be zero current and zero power, but the power. So the remaining power comes from the grid. Now, later the main block demand increases. Let's say the main block itself now demand increased to 200. So now we have 200 plus 100 plus 100. 400 is our demand. Whereas solar is still, let's say, at 170. So the 400 minus 170 will be the grid power. I think it is about 230 will be the grid power. So this is how we calculate. It may happen sometime, let's say it is on Sunday. On Sunday, the academic institute or the campus is closed, and all these things will have very minimal load, maybe 20 kilowatt, 20 kilowatt, and 10 kilowatts. So total demand itself may fall to only 50 kilowatts. Whereas the solar power being generated in the afternoon on Sunday, maybe it is close to again. Let's again take the same example: 170 kilowatts. So 170 is generated from solar, but only locally you are consuming 50 in the campus. So remaining 120 goes back to the grid, and the grid is supposed to pay you some money. So because you are returning power to the grid, so all such things happen. So this is the actual connection. Now in the next slide, I have shown the meter numbers. So if you look at the meter number 10, it refers to the power consumed by the cyber and digital block. So that's a kind of a building. And main block is another building in that campus, and high tech block in it. These three buildings are the main buildings which covers the entire power consumption. And meter number 7, meter number 10, meter number 12, and so on will be like that. Now, why there is no meter on the grid? So, unfortunately, either there is no meter at all, or the meter which is there is actually under the control of the utility grid. So, therefore, we are unable to fiddle with the grid, that particular meter, and extract data from it. So, the data there is no. I mean, we should install another meter and get the data, but then there is other way. As I explained before, using the what you call the uh, addition of the supply and from that subtraction of the demand and all, we can actually calculate what is the grid power. That we can do it later, but for the time being there is no meter on the grid, for example, right now for this, it's just one layer of complexity that it used to. Okay, now let's say I'm interested in the main block. Okay, so I just go back here. Now, I already plotted the data frame, right? So here you can see meter ID 12, 4, 6, 7, and 8. By the way, 4, 6, and 8, these numbers are not shown in this diagram. So they are some other locations. Further down main block, we'll have again a subdivision and there are smaller demands and all. So we have more data actually, not only these meters, there are close to 50 meters data we have. But right now we are interested in the main electrical layout connections. Okay, so we want to ignore the other meter IDs. Okay, so now I want to only filter out the data where the meter ID is equal to 7. Okay, so let's do that. So how do I do that? So simply I go for BF and I give like this, and then here BF dot meter ID double equal to 7. Okay. So if I do like this, what happens? This particular internal condition will filter out the records where the meter ID is matching to 7. And those records index will again be referred by DF, and then I'll be getting that. And now I'll print this instead of printing the entire uh, data. So let's say print of this. So this is how we filter a particular data. Okay. So now I save it again. Let me execute the code. Okay. So once this code executes, I am expecting only the meter 7 data. So again, now you can see we have meter number 7, and we have 23, 55, 56, 57 up to 23, 59. Meter number seven's data is there. So in the meter ID column, only meter number 7 is available. And here you can see 1430 rows and 29 columns. Okay. So again, pay attention to this number 1430. What is this 1430? Okay. So I just open a calculator. So let's say 24 hours multiplied by 60 minutes in each hour. So in a particular day, when there are, I'm sorry, I'm not connected here, but anyway, it's okay. In a particular day, when there are 24 hours, so basically 24 multiplied by 60 is actually equal to 1440. Okay, so per day I am expecting 1440 records, but then here only I am getting 1430 records. So if you see here in the results, here it is showing 1430. That means somewhere 10 minutes data is missing actually. So I don't know where it is right now, but we can always figure it out. We'll do it in a later part. But then let's say I will store this M7 data. So the data of meter number 7. Okay, so I'm just, instead of printing, I'm storing it. And from that, I also want to, if I want to filter out only the PT, total power. Okay, so I can do that also. In fact, I'm not total power, or let's print it in, let's keep it there. Now, how do I plot it? Okay, so I already have this PLT, right? So now here I can say PLT dot plot. Oh, I'm sorry, M7 data. I think command for plotting is, let me just refer to my cheat sheet. Yeah. Okay, so here dot plot. Okay, now I want a line plot, a simple line plot, and then the parameter that I am giving. See, in the M7 data, I am only filtering out the PT, total power, okay, and then I want to get a line plot of it. Okay, then PLT dot show. So very simple, 10 lines of program. Just I am reading the data from the CSV file, assigning the columns. After assigning the columns, I am filtering out the only particular meter number 7, and then creating a variable. And then from that again, I am filtering only the PT, and then I am plotting the data. Okay, so let's see whether this works. Okay, so I save it, run it. Okay. So immediately now I can start now getting the data, something like this. So here the x-axis will be the time, and then y-axis will be the power. Okay, so and then we can see some kind of a power curve kind of thing. So this is typically expected in the morning or in the midnight onwards. The power is only about 10 to 12 kilowatts. Then as the morning happens, the power increases, and then this is the working hours of educational institute, and towards the evening again, power flow goes down and it becomes small. Okay. So of course, this is not a proper plot. We need to give proper timestamps on the x-axis, proper units on the y-axis. We need to give a title. We need to give a legend and things like that. So, and we will see how to do that. That just instead of line, if I say area, so just to show us slightly different view of it. So we can get an area plot like this. So both are basically same, but here we can get the area plot. Now, instead of meter number 7, so again, if I go back, let's say I'm interested in the cyber and digital block. Okay, what is the pattern of that? So let's see if we have any data from that. Okay, so here the meter ID filtering, I'm just changing it to different number, and then again I'm executing. So here you see slightly different pattern you're getting. It's not exactly the same pattern, but it's slightly a different pattern that you're getting for this. So there is a facility here in Matplotlib to zoom a particular region. So here, it looks like, 14. So there is a 1 kilowatt load which is coming on and off. This might be some small equipment which is again interesting to study. But just all this analysis, when you visualize, it will look good. I'm sorry. I'm going back to home. And here you can see there is a huge reduction in one particular from 85, it's coming back to 55. So probably an air conditioning system might have been switched off here, which is worth 30 kilowatts. Okay. So you can actually see that pattern. This is a lunchtime basically. So during the lunchtime, see this is the morning hours, and there is a lunch break, and then there is a evening hours, and then it is going back like that. So one more meter. So again, if you see here, 12. So if I say 12, again if I run, I'm just changing the meter. So this is again a similar pattern you can see. Just a different block, different building, and again you can see that and looks like the morning session was more busy than the afternoon session. So maybe in the afternoon session there are less activity. There's less activity in that building. Maybe more activity happened in the morning. So sometimes, so this is a typical pattern, M-shaped pattern that you can see in educational institute campus. During lunch, the demands will reduce, and then there will be, and you can see huge increase in the morning, and then and so on like that. Anyway, we the moment we start now plotting, so many interesting observations start coming. Now, what about 3, 5, and 2? Okay, so let me disappoint you a little by just now. I want to know what is the solar data. So, if I go for solar data, so it's just coming as empty. Why? Because this particular file which I mentioned in my main source, this particular file does not have the solar data. Okay, so if I open this, here the meter ID 10 is there, 12, 4, 6, etc. is there, but there's no meter ID 2, there's no meter ID 3 also. So the supply side, we don't have data in this particular file. We only have the data on the demand side. But anyway, so right now we got a sample plot. Let's further analyze this, and then we'll come back. Now, instead of total power, let's say I'm interested in calculating the energy, for example. Okay, so energy means the energy consumed by the meter. So that will be gradually increasing. So let's say energy, and then here I will say line plot. Okay, so what is the energy consumed? So let's see that. So I can now select any particular parameter, and I can plot it and then see how it goes. Okay, so this is how the gradual increase in the energy. Okay, so from one morning to evening. So let's say this is 90,800 units to begin with, approximately I'm saying, and then what you call 91,400 units. So approximately from 800 to 1400, about 600 units of energy has been consumed by which one? Okay, the main block. So the 600 units of energy is being consumed. And what is the cost of the 600 units of energy? It's probably around 6,000 rupees, because you can round up to 10 rupees per unit. So it is about 6,000 rupees. So later we can also analyze how we can save on energy and all these things. Anyway, so this video is getting long. So what we have done is simply we just added 2 3 lines of code, but understand how this is working. So df dot meter id equal to 7. This is a condition, and then here I can select any particular this thing. So let's say I'm interested in power factor of R phase. Okay, so again let's study the power factor. So let me close this. So you can, whatever parameter you want, you can print it and see. So again, this is interesting. See, power factor must be close to 1. When the power factor is very less, 0.5, this indicates that your performance of that particular demand is bad. It's a bad type of load. Okay, so that is another interesting observation that we can note here. The poor power factor in this. Anyway, so there are how to plot multiple things and how to see the other things. Now my curiosity has spiked. So now I go for power factor of Y phase. So different phases will have different power factors. So let's see. Okay, so this seems to be okay, except somewhere in 3 places it's going to -1. Anyway, so we and power factor of B phase. So in just as a sample, I'm plotting these parameters and see. Okay, so this is again even worse. It's in the range of zero point 0.2 power factor. So one typical thing that we now already observed in this particular campus diagram is that the main block has a poor power factor problem. Okay, so the power factor is poor. Okay. So this is immediately one thing that we need to address at this particular, because a poor power factor will increase your electricity bill. See, if I now plot instead of active power, if I plot ST, okay, so ST is total power. So here you can see the total power is about 30 kilowatts here, the apparent power, whereas the actual power was about 11 or 12. So the amount you pay for 11 or 12 kilowatt versus amount, maybe I'll just try to plot both and see if it works. So now I want to get PT and HT both. So notice how I am so total active power and total apparent power. So two columns I'm taking, and now I'll do a line plot for this. So let's see how it works. So here you can see now, when the power factor is high, both are almost matching, so no problem. So here, instead of paying for consuming 10 kilowatt, you will be paying 3 times more money for consuming 30 kilowatt. So this is a because the billing is done based on the blue line, whereas the actual consumption is based on the orange line. So you are paying more bill. So immediately we can again notice that here in this case. Anyway, so this is a never-ending thing. We keep on analyzing it. It will keep creating new things. So let's get back to this and then see how what happens. How to do further analysis on this. So there are still a lot of problems. How can I introduce timestamps, and all these things is there. So how can I identify null values, how can I identify missing data, all these things that we will do in the next videos in this playlist. Thank you.